next up we have somebody who should be a familiar face to pretty much everybody here. Stephen Heminger has contributed a lot to DPDK over the years and to many other open source communities. He's going to talk about DPDK and HyperV.
Thank you. So today I'm going to talk about upcoming support of DPDK, HyperV support in DPDK. Where's the magic button? Here it is. I'm going to go really fast over HyperV. I assume that A, I'm not the person at Microsoft that knows the most about it. And second of all, I think a lot of people here are pretty familiar with it. I'm going to talk about a little bit of backstory on the DPDK HyperV and a roadmap of where I want it to be in the short term, medium term, and long term. And a lot of that I want to key off discussion here, not quite as much as we had in the first session, but I would like to open up concepts about how we want to go forward with some of the features and get feedback from people before we get really involved. HyperV is a hypervisor core infrastructure, just like KVM or VMware. It's been around a long time. It was originally done as a research project. It was integrated at Microsoft back in Windows Server 2008. It's in Windows Server 2016. It's actually available in Windows 10 as well, so you can run it on your laptop. It's the core for the Azure cloud, and I was surprised to discover that actually Azure cloud has a slightly different variant than the version that's in Windows Server. So that's just basically, internally what it means is we got two test platforms to deal with. Similar to, I know that people are familiar with Zen versus Amazon. They're sort of the same, but they're different. And there's actually two generations of HyperV in the two different generations of guests in the current version. There's the legacy version, which typically most of your Linux environments run in, where you have a legacy BIOS, you have the optional E1000 kind of emulated devices. And the newer stuff, the Gen 2 stuff, has VM with UEFI secure boot. It has no emulated devices, and it also supports some things with encryption as well. We're working with the enterprise distros, and that's going to be there. It's supported on Linux, but for most of the developers here doing testing, they're going to want to choose Gen 1 kind of environments. So this is the architecture slide of HyperV, and I wanted to bring up, I had a nice slide to kind of do some comparisons, but it didn't work out as well. This is very similar to what you see in any other guest host environment. You have guests, and the guests all have a virtual interface to the hypervisor. They don't talk to real hardware. And if you're familiar with KVM, what you have is you have a PCI bus. And in HyperV, we have VM bus. And the difference there is kind of subtle. In PCI world, you have addresses with domain, bus, function. In VM bus, devices show up having a GUID. So they have a different addressing scheme. In PCI, you have emulated interrupts. So you have emulated MSIX. In VM bus, they have the concept of channels, and they basically have one interrupt per CPU, and then that's fanned out to the channels, and you can bind a channel to a CPU. So basically, there's some architectural differences, and in general, that doesn't affect the DPDK, but what it does affect is, if you're familiar with the internals of DPDK, the full mode drivers have hooks into a PCI infrastructure. And in order to support it on HyperV, you have to generic. Now, some work has been done recently in the current release to kind of split that off, and this, which made life a little more difficult. In the original version of the HyperV DPDK support that was done by Brocade was precursor to that, so this, each code needs to be fixed. And the original version that was done, that Brocade did, if you look at the Linux side, you have VM bus, you have a NetBSC driver, and it goes up the stack. Well, the HyperV DPDK side, you've got VM bus, you want to have a generic interface in the kernel, just like you have a generic interface to PCI, and you want to move it all into user space. Well, the code that was written basically had, well, we have a Hyper-V driver, and we'll kind of steal some of the kernel driver bits to steal some data structures. Oh, and by the way, the user space here kind of depends on, so the first step that I've been taking on is disentangling that to try to make it a generic architecture. So what we want to do in the initial DPDK release is have a generic UIO driver, like we have a generic PCI driver, and get it upstream. So I don't want to have a kernel component in the DPDK that you have to build on your distro and then get into some enterprise distro. And so, and likewise, I want this to use the generic VM bus implementations that are in the kernel to map the three parts, the three memory regions that the network device shows up. So at the network device in Hyper-V, well, pretty much all of them have interrupt, monitor, and receive and transmit rings. This one is basically, think of this as the read-only page from the host saying, hey, you've got an event. And the other one is the write-only page from the guest, where the guest writes to the host saying, oh, go look at this ring, and then you have receive and transmit rings. So I want to reduce it down to the core set of stuff in the kernel, just like you have the core when you expose a NIC, and move all the other stuff into the Hyper-V Pulmo driver and user space. And the reason behind that is I want this to be a long-term stable thing where we can work internally and improve the Linux side driver. We can work in the community to improve the Hyper-V driver, and the two don't clash into each other as, change the layout of this, change the layout of that kind of problem. So I mentioned that I call it the 0.1, the unreleased code that was contracted by Brocade to support Hyper-V. So it's perfectly possible to run a DPDK application on Hyper-V. It's just not in the release tree. If you want to get that, talk to Brocade, they'll probably send it to you. I used to work there. They gladly gave it to me saying, you want to work on it? Go for it. And the plan is to get a 1.0 version in the 17.04 release, and this will be joint work with Microsoft, mainly on our side, will be the testing, and Intel working on integration and all the other platform issues. And I want to get the basic functionality in there. So I'm not going to have every offload feature that Hyper-V has. I'm not going to have, multi-queue support. I'm not going to I may even, drop jumbo frame support. Just get down to the core functionality, get the architecture nailed down, and get it so that people can start writing applications, and they'll work on Azure, they'll work on Hyper-V, Windows Server 2016. And then later on, go address a lot of the core performance issues. And I'll go a little bit SIRV. And also, right now, the scripts in the DPDK, a lot of them depend on the sysfs layout for PCI. So like the NIC bind script, that Python script knows it's PCI. I probably won't get to fixing that in the 17.04 release, so you manually have to go unbind and rebind with the shell script. Those kind of things. The other thing is the code, the initial code has many copies and spin locks The spin locks are partly because I think the original developer did not understand the DPDK model of one process owns the queue. It's not going to step on itself. And some of the copies have to do with the fact that they're staging buffers. But we fixed most of those on the Linux side, and the same stuff can be done on the DPDK side. So a lot of this, I expect the version of the DPDK driver here to be quite well performant relative to the Linux side. It's not you won't use it, but I'm sure we'll get 2 to 4x improvement really easily right away after that. Also, I mentioned the UIO API. Right now, the HyperV UIO generic driver that I just submitted, I think by later in the year we can get a more VFIO style API so that we can support multi-key better. We'll keep the old one around because it's generically useful for lots of other devices, but I want to have a very similar API as we have on PCI, but that means writing more kernel code and more complexity. So the idea is get a usable, stable platform for customers right away in the next release, and the follow-on release, pump it up. And just to give you an idea about offloads, so I just chose the Intel 10 gig NIC because everybody in the room is familiar with it. And I have this big table of all the features and cut it down for a slide. But basically, if you're in hardware, you get 9K MTU, you get hardware limit of RX and TX queues, LR not really enabled, and you get a bunch of filtering. When you get to virtualization, you get a different set of features. You get a much bigger MTU because it's all basically done software. You receive and transmit queues, that's a software artifact. There's no reason that you can't have as many as you want. In both cases, unless you've actually got the host doing some kind of aggregation, you really don't get LRO. There's work being done to do it in KVM. VMware does it internally, and there's plans in the future to do something like that on HyperV as well. Everybody does segmentation offload, but the actual multicast and VLAN filtering, the HyperV host doesn't do that right now. So what that means is if you're going to use VLANs, you can use VLANs, but there's no thing that says, I'll get just this subset of them. And my goal is to get as many of these supported in the 1707 release as early as possible, but really not until later in the year. The first release may not support, for example, all the receive and checksum offload possibilities because it's just a scope issue. The other big thing here is the way we do SIRV in HyperV is different than it's done on other virtualization platforms. So SIRV is, you basically take a physical device and you split it out to multiple virtual function devices. And the way that the hypervisors handle that is they pass a virtual PCI device up to the guest. On HyperV, what happens is, as soon as you do that, and when you do that, you can either do it super duper PowerShell wizardry, or you can go in with the HyperV Manager GUI, and you can click, oh, I want to have this vSwitch, have this device be SIRV, and that this guest can have it. And when you do that, the guest gets 2 devices. One, it gets a synthetic VM bus network device that looks just like a synthetic network device that existed, but this one is always a pair. So you get a VF, the hardware, and you get another synthetic one. And well, why is that? There's 2 reasons that happens in HyperV. The first reason is that in order to allow guest migration, these 2 are bonded together, and I can migrate the guest, and when that happens, it shuts off the VF device, moves the guest, and now it gets the VM bus device to give another VF to it. And people do this today in KVM environments as well. They do migration, and even in VMware. So the Hyper-V support is there in Windows Server 2016 and Azure. The question is, how do you deal with this on the guest? Well, the way the Windows guest works is all this is hidden in the Windows driver, and there's a bonding internal, and the two devices never show up. You only see one bonded device. And we made the choice on the Linux support to say, we'll expose these two, and we'll have a standard script to create using the standard Linux bonding infrastructure. So why am I telling you all this? Well, to support this in the DPDK, we have the same issue. And there's another thing going on too, which is the switchover and the management of this has to be done in the NetBSC driver. Also, any broadcast or multicast packets come in on the PF and actually go through the vSwitch in the host, and then are re-injected in the, show up on the virtual synthetic device, not on the hardware. And the reason behind that is that the host wants to have access control of multicast and promiscuous and broadcast. And so because of that, it goes through the host software first. So what does that mean to support SIRV and Hyper-V in the DPDK? It means we need to have an ability somewhere in the Ethernet driver model to get notification when some other device state changes. So when somebody brings up the VF device, the DPDK poll mode driver for Hyper-V has to go explicitly ask to make that association between the network synthetic device and the VF device. We need to be able to take packets that came in off the NetBSC device and somehow make them show up in a way that's going to work well on the other device. Now, whether that means as simple as just changing the flag on the MBUF about which port it came in and assuming the other higher labels work right or not. And the way the association is done today in the Linux driver is we look for the VF and the synthetic device that have the same MAC address, and we know those two are paired together. There's also some metadata in the host that has serial numbers and stuff. I'm not familiar enough with that, but I think we need to basically be able to get that same kind of metadata so that from an application point of view, you know these two go together. There's a bonding driver in the DPDK. We need to make sure that works well together, and kind of we need the example of probably the initial release of SIRV support will be kind of like the examples of here's an example how to use the bonding driver with Hyper-V and the DPDK. But from a user point of view, we really need to be able to have kind of a zero-conf setup where I discover an application and the initialization discovers the two, sets it all up, and we don't have to make the application go write a bunch of management layer to deal with all this. So that's kind of the short and medium-term roadmap. Longer term, it talks internally and with Intel about how we can improve the communication between the guest and the host in Hyper-V. A lot of this, I'm most familiar with VirtIO is just going through a revision that's not finalized yet of basically how to reduce the amount of cache misses on virtual drivers. And the same thing, the same technology and the same discussion applies to Hyper-V world. Microsoft is much more open now. One of the options on the table is can we support VirtIO on Hyper-V, and what would that look like? This is just kind of like, nobody's committed anything. This is what we're thinking about discussing it. And in this community, if people have better ideas and want to give feedback and what would help out, that would be great. that we have some other things that were technologies that were done to support a DPDK-like function on Windows called Direct Path, and can we leverage that, bring that in? How would that work in the DPDK? The other one that comes up on this is how can we kind of go back to the first thing people mentioned this morning. How can we have guests with better security in this world? Because right now with the DPDK, you're basically exposing a lot of the hardware, the user space to the application. There's a lot of problems with that. What can we do to partition this, make it safer? And specifically, I mean, the simplest case is the way we share channels. What if you had a malicious DPDK application that was saturating the guest interface to the host? I mean, you'd get things like you could kill the storage if you had a bad network app. And the same is, if this isn't a Hyper-V specific thing, I can do the same thing on KVM. I can kill VirtIO if I have a malicious VirtIO app. And lastly, there's been some like wild speculation about can we bring DPDK support into the Windows guest? Why would we want to do it? What would it? What benefit would it have? What would the technologies be? And you know, various people have done various hand-wave things in the past about that. So that's what I had. I had one other thing, which was after I heard the first talk this morning. In case you didn't know, the noun of collection for starlings is a murmur, and I said, well, what's the noun of collection for a room full of DPDK developers? And I think I came up with the answer. It's a hash of DPDK developers. A random selection. So, any questions? I welcome back time. Vincent?
So two questions, in fact, Steve. First is about with VM-bus. I mean, as you know, with PCI models, we are limited to some number of devices per VMs, which is a big issue with QEMUs. What's about VM-bus and what is any limitations? Is that the first?
There is no limit that I know of, but there probably is some table somewhere in the host. But I don't think it's very small limit. There is some other issues that we have. I don't think it'll show up in the DPK world as much, but for example, if you deal with the systemd world, they also have PCI dependencies. So right now, if you run a Linux guest, you always get the ESL device because systemd doesn't know what it is. But that's a good or bad thing, I will just get it. But also, when you get to SIRV, you get the flip side, which is that PCI bus that shows up in the guest is numbered with a very large number because it's a synthetic hash number. They intentionally don't want it to conflict with the regular PCI bus over here, which then confuses systemd and it generates huge names.
Yes, and the next is about the security for the guest. What's about using some kind of RDMA for the guest?
There's talk about that, but it's not going to be. The devices aren't going to provide. The VF devices aren't going to have an RDMA interface for all of the devices, so that's not the solution. It may be a solution if the device supports RDMA.
Excuse me, it was a mic. About DPDK in Windows, 2 years ago, I think, in the first DPDK summit in San Francisco, there was someone from Microsoft explaining they were working on something.
That's the direct path stuff, which is the re-implementation of a DPDK-like function on Windows.
What's the difference?
I can pull out the paper, but there's different APIs and there's different underlying technologies, but they're basically the same.
So, do Windows need DPDK? If there is
it comes down to there are DPDK applications. It makes sense to to have them as a, I mean, we support BSD and Linux. If we can support Windows as well, people could run the applications on there.
Hi, Stephen. I just want to clarify something. I'm not sure if I fully understood earlier. For this work to get a driver in DPDK, is there a kernel dependency that we need a kernel driver?
Okay, you're going to need a kernel driver. The plan is to get that into 4.19 upstream. If somebody wants to backport it to whatever enterprise release or whatever, that's their thing. I will not put the kernel driver in the DPDK because I don't think that's a maintainable place for it.
Okay.
That was kind of intentional. I didn't want to get into the IGB UIO problem of having something that had to be supported on SLES and RHEL, and you put to 16 flavors.
Okay, no, I just wanted to clarify that. So there is a new kernel component going to be needed, but you've already got plans in place.
The other thing is, Microsoft works upstream on the Linux driver, and then for the enterprise distros, works to provide a technology long-term stable base that they integrate back into their enterprise releases, and we'll put the HyperV support for DPDK in that same bundle. So, you can ask for it, but that's not how you'll get it, but we'll work on getting it into the enterprise releases, and it'll be upstream so further.
Okay, thank you.
Hi, I'm Chen from Intel. I'm interested in the DPDK support for the Windows guest. So I think there will be some challenge here that you cannot see the Windows code, and it's very hard to debug if you have seen some issues.
Well, this is all user space on Windows, so you can. It's just like you can build a Windows app today. I mean, Visual Studio build a Windows app. It would just be Visual Studio built an app that's DPDK based. It's just about getting the right support to get the equivalent of UIO in Windows, and there is some of that, but I'm not familiar enough with what's there. And
okay, yeah, since maybe people will ask the comparison with Windows default, such as Windows kernel interface with your user space interface. So yeah, it may be very hard to debug for the.
Yeah, and the other problem is that's related to all this is on Linux. It's not easy, but it's possible to do all this pinning to CPUs and all the application management issues. That gets much harder in the Windows environment. So, I mean, there's certainly second order or more complicated effects. That's
okay, thanks.
I have a question about the hypervisor and the package path through the hypervisor, where I understood that there's a kind of a exception path
that one?
running through, that one, running through the HyperV switch, and then the fast path running through the PCI port and the VF.
Yeah, basically, the normal thing without SIRV is all packets come in, go to the network card, go to a virtual switch inside the hypervisor, and then go off to the guest. Kind of like in the KVM world, everything either goes through OVS or a bridge and then goes off to the guest. So we have pretty much the same architecture going on in HyperV. The switch is different, management's different, but same. So when you're at SRV, you basically have an accelerated path to the guest for those packets. It's all the packets that don't match this MAC address that have other things that you want to get through.
And that's my question, because I noticed that you said when you're in promiscuous mode.
But it's like whether you're allowed to be in promiscuous mode,
okay.
And all those other things are a function of the virtual switch on the host side.
So you are allowed to be in promiscuous mode and go through the fast path?
You never get packets through the fast path in promiscuous mode.
Okay, so Okay, that's a performance thing.
So it's basically
The reason I'm asking is that we're making a transparent appliance that doesn't have a MAC address.
right.
It uses one vSwitch on the downside and one vSwitch on the upside. So you have your firewall,
Yeah.
vSwitch running into our appliance, then a vSwitch connected to your...
Yeah,
Whatever
you're
service,
basically going to have to go through the security domain in the host.
So all the packets will have to run through the exception path.
Right. Right. Because of that they've done this for security reasons where they want to isolate the guest.
And that's never going to reach
Now,
1 or
I
10 gigabit.
admit that my experience with Windows is very short, and I'm sure that there's a lot more things going on, and I'm sure that there's, ability to do a lot of other things. I'm sure you probably can pass the physical device up to the Windows guest instead. I mean, it may very well be in this case you don't really want a real SIRV support.
But they put a virtual firewall in front of our appliance, so we don't have a physical port in that case.
Right.
And typically when it's deployed virtually, it's because they want a one physical box solution where they have the firewall and the whatever server and the benefit optimization plans. And that's not really high performance on the HyperV then. Do you know if there's any roadmap to support that?
I'm not familiar. I can talk some more. I didn't even realize that this was a requirement that was coming up for those class of systems. But
it's generally the hypervisors are designed for running a lot of servers where you have an IP address and a MAC address and a single port. So having multiple vSwitches connected to the same appliance is also relatively new for even VMware. I mean, they had it before, that it's relatively new that it's working.
Yeah.
Okay, thanks.
Okay, I guess we should probably thank Stephen at this point.
Oh, yeah.
So we're going to take a break now.